All right. Well, we are at time, so let's go ahead and get started. All right. Thanks, everybody, for joining. Welcome to Code Connect 2020. Hopefully, this is an annual recurring thing. I think it's gone so far pretty good. It was really encouraging to see Pat come in and speak, and then yesterday having Kit. It's just awesome to see VMware really take developers seriously, and you can see that through our whole portfolio. It's all about enabling developers and opening up the floodgates so that they can be more productive, both from like the IT administrator's perspective of like giving the ability to deliver that infrastructure without having to know every little bit that goes on inside of it, but at the same time give developers the tools that they're most familiar with to get their jobs done. Like baking Kubernetes into vSphere and into VMware Cloud Foundation, it's a no-brainer. And so Fusion and Workstation, we get to extend that a little bit. We borrow a lot of code from the enterprise hypervisors. So ESX shares, Workstation and Fusion's code. And, we'll look at that in just a second. But so, with Fusion 12 just coming out, we've, we released it a couple weeks ago. We've got Kubernetes support built into it, as well as containers. It's using our container runtime based off of Project Pacific. And we work with folks inside of the Kubernetes community, in the contributor community, particularly focused on kind, and to make sure that we could support that as a first-class citizen. So we're going to show a little demo today. I'm going to pull some images. We're going to build some images. We're going to do it the container style. We're going to put that into a Kubernetes cluster, and we're going to show how that all works. Hopefully my other machine over here plays nice, and OBS plays nice, and all the networking stuff plays nice, and we're going to have some great demos. So I don't want to go through too much presentation, but just to kind of set the stage here, we'll do a little bit. So as I mentioned, I always like to kind of start with this slide. It's actually a shot of our campus. And the reason is because, we're always on this journey, and we're always moving forward on it. Things are always changing. So it's super important to stay ahead of the curve and stay on top of things. And it can be really challenging in today's world. Everything's changing so quickly. If you just look at the Cloud Native Computing Foundation, the landscape of all the projects that they've sponsored and are a part of the community, it's kind of dizzying. But things like Code Connect and VMworld and all these other conferences that spin up are really great ways to get high value out of your time that you spend in front of all these Zoom meetings that we're doing these days. So, I mentioned back in '99, we did this crazy thing. We made a computer run inside of another computer. It's kind of incredible. And we did that because, we had some problems we wanted to solve, and we also had a bit of an engineering itch we wanted to scratch. And that became what today is ESX. But interesting, a lot of folks actually don't know is that, the first thing that launched was called VMware 1.0. That product is today called VMware Workstation. We have inherited that code. It's lived with us throughout this whole time. So it's really great that we have the same hypervisor at the desktop and in the data center and in the cloud to give you that very easy, seamless workload portability, that same platform that you can know and trust on. I won't go too much further, and this is just a bunch of stuff from my VMworld presentation, but again, just to set the context. When Apple switched to Intel in x86 in 2006, in 2007, we were able to basically take Workstation and port that over to the Mac, and that is what we call Fusion today. So we're going to be looking through the lens of Fusion, but all the features that I'm going to be showing off actually are also applicable in Workstation. We did make sure that our container runtime would work on both Fusion and Workstation, and that's shipping in Workstation 16 and in Fusion 12. As we see here, those links at the bottom there, they'll take you right to where you need to go to, learn everything you need to know about Fusion 12 and Workstation 16. So we're focusing more on the top line, which is folks that build software and there's a lot of other use cases, but we're going to focus specifically on some command line operations. The only UI you're probably going to see is, by accident on my other machine as it's sort of showing up there. But one thing I do want to mention is all the stuff that we're showing here today is available with Fusion Player. Fusion Player is our personal use product. It's free for anybody to use. You can get the URL right there. That'll take you to a registration page. You get your free copy of that, and away you go. So our release this year, we had a few technical themes, but again, we're going to focus on the Kubernetes and the containers portion of it. So we basically took Containerd, we built it on Mac. We did a lot of extra stuff onto it. We merged it with our CRX runtime. And that CRX runtime, again, is the Project Pacific container engine that's powering all of the really cool vSphere with Tanzu workloads that are being driven from the workload management sort of UI inside of vCenter there. And so we just, we've had vCuddle in there for a couple of months now. We were shipping it in tech preview. And as we released our Fusion 12 and Workstation 16, we added support for Kind. And if folks aren't familiar, Kind stands for Kubernetes and Docker. And it's basically a way to spin up Kubernetes using a series of Docker images. And Kind is a binary that can basically communicate with the Docker runtime and goes ahead and does all the magic. So we basically took Kind and we didn't do anything to it. We actually changed the system around a little bit so that it thinks it's actually talking straight to Docker. And that's what vCuddle sort of delivers for us. So I'll show you how that aliasing sort of works there. But the cool thing is, without Kind, even regardless, we do have containerd exposed. So that sock is there. And if you wanted to, if you have a containerd compliant, app that knows how to talk to the containerd socket, by definition, it should work. And we're, totally open to talking to folks who are trying to make things work. And if you run into any stumbling blocks, we really want to expose that as an API surface area. So like, why did we do this? Is my PowerPoint going to crash? I think my PowerPoint's going to crash.
Well, because you're not running in full screen, presentation mode, it scales it down, right? Which is nice because we see you, but I think Chris's comment there is, yeah, if you run it full screen, I don't know if it'll.
Well, I only had the one more slide, so it's not that big a deal.
Ah, I see. Okay.
We can get right to the demos.
All right. No worries. Thanks a lot.
Yeah, no, thanks. The last demo the last slide basically just says, the relationship between vSphere and the desktop. We look at it in a series of loops. Basically, there's two loops. You have your inner loop and your outer loop. So your inner loop is this like rapid hacking your code, making your thing work, iterating it locally on your desktop. And then when you're happy, everything's cool, you basically commit your code into Git, pipeline magic takes over, and that's the outer loop where all of your automation picks up, takes your, your source code, Docker files into it, builds your Docker images, throws those containers into a cluster, production, staging, et cetera, et cetera. So the great thing about having the same technology on both the desktop and in the data center is that the considerations that you'd have to make if you're running things on different architectures don't necessarily need to apply. And this is great because you can sort of have an expectation of, what your app's going to do in the cloud when you run it on your local environment. So I'll start off with just run vCuddle here. Actually, yeah, this is cool. I think that, let's go one a little bigger here. Right. So, vCuddle in and of itself, it, can do a whole bunch of really cool things with container images. It's a little older as far as like, if you're familiar with like brand new Docker syntax, it does kind of have that old school familiar Docker feel to it. And we wanted that, very deliberately because we didn't want to really reach too far into like mimicking every single command. And we do have a strategy, I think, going forward of how we're going to basically facilitate that without necessarily having to re-implement it. And, there's going to be some more parity stuff coming around as we evolve this project, which, when we started, we called it Project Nautilus. So if you hear it around Project Nautilus, this is basically what that is. It's an internal name that we use to sort of help us North Star what we are trying to do. And that results in, Fusion and Workstation having container support. So I've already taken a little bit of stuff here. So for example, actually, let me just do this. Back into my dev directory. What I did was I just exited because I was in a double shell. So what I'll show you is vCuddle kind. And basically what this command, the single command does is it aliases all the Docker commands to vCuddle commands. So if I do Docker, this is the same vCuddle output that we had before, which means like things like kind, create, cluster will just work. So that's going to go ahead and create us up a Kubernetes cluster very quickly. But while that's happening, I'm actually going to go ahead and just show some native container stuff. That's going to take about 1.5 minutes, 2 minutes or so. I forgot to run time at the beginning of it, but I usually do that. But the initial creation of the kind cluster, the very first time you do it, takes about 4 or 5 minutes, depending on your hardware. And every time after that, it doesn't have to rebuild some of the images. So it takes about a minute to go ahead and deploy it. You can see it already just starting to get the control plane going here. So coming back, I'm actually going to go ahead and pull. Let me take a look at my images. We have the kind node there, but I'm going to pull one of the images that I use for my website. It's a very simple Docker container. If you look at actually the directory that the Docker image is created from, it's basically this. I use a tool called Hugo, which is a static site generator. So it takes markdown files, creates HTML out of it based on the theme, and it serves it up in a very static Nginx static content HTML type of way. So it's really cool because it gets you to see sort of that pipeline experience without necessarily having to have something that's very complex with a ton of dependencies. You get to sort of, for me, it was a way to learn how to really stitch all these different pieces together. So it, gets built by a CI engine. When my Kubernetes deployment detects that there's another version of it, I have a Helm chart that goes ahead and redeploys a new version of the site, and it's all very automated. So I can just sort of check in my source code and to like a new content thing, and it'll go ahead and rebuild the image. But we're going to do a bunch of that basically manually here. So if we actually, let's just do this. I'm a visual kind of guy sometimes. We're going to look at the Docker file real quick. So it's a very, very simple thing. It's just basically built off of another image, which is the Scott Wells image here. And it creates a work directory /app. It copies the existing folder into the app folder and then runs the Hugo command to actually build the static site. The extended does the static site generation. And then, so this is a multi-stage Docker file. So it'll then go ahead and create an Nginx Alpine image, and it'll copy the output of that Hugo extended and then pop it into the user share Nginx HTML folder to basically put it in behind the Nginx. And that error is because the plugins, it's not working. I wasn't trying to make it work. So Docker file, and this will be our deployment when we get to that. It's a very simple Kubernetes deployment, but I'll show you what that sort of looks like in a moment. So we're going to go ahead and I'm going to do two things. We're going to start and we're going to pull. So we're going to go. Oops, helps if I put the right command there. So it's going to download from my public GitHub repo, my super awesome website. And then what we're going to do is I'm going to fire it up in a container, and then I'm actually going to access it from a remote machine here. So we've got the image now pulled. We got little images. We can see it's there. I'm actually just going to tag it. Yeah. We're just going to call it CC demo because it's easy like that. So we're going to run. So I'm going to run. Obviously, I've done this before, so I'm just pushing up and letting it. I'm using Z shell, so ZSH. It's remembering my history here. So we're going to do vcutl run. The name of the container that we're going to create is going to call Hugo demo. It's going to get a TTY. We're going to do it as a daemon in the background, and we're going to call up the CC demo image to do it with. So. And this actually, while that's kicking, we should just take a look here. We can see kind has been started. So actually, if you do VM run list, you can see that we've got the Hugo demo already started, and we've also got the kind control plane started. So these are the two VMs that are running the CRX runtime. That one of them is the kind control plane, and the other one is this Hugo right here. So if we do vcutl ps, we can see we've got all of that there. It's falling over line here, but basically here's the IP address of the Docker image that we're running. So what's cool is we can just actually go like this. And so you notice I didn't do any port forwarding. I didn't, I didn't need to specify any of those parameters. This is just sort of running you know, as the native container is right there, and woo, fancy website, right? So actually, I'm going to stop it, and I'm going to actually we're going to run it again, but we're going to give it a port, and we're going to go, what is it? I feel like I got that backwards. I always get it backwards. I always second guess myself. Oops, CC demo. Okay. There we go. And there, so Hugo Demo 2 is running, and it's forwarding port 80 to port 8080. And like I said, I always feel like I get the in and out backwards, but here we go. Moment of truth. So I'm actually going to split over to my other machine here. So let's go ahead and open up my browser. And the IP address of my host is actually 10.0.10.49. So we're just going to fire it up. And yeah, see, I did the thing. I knew I was going to do that. So let's go ahead and stop the container, and we'll try this the other way. Okay. Hugo Demo 3 firing up. And yeah, let me just bring that up. Okay, so that's running. There. Like I said, I always get the internal and the external ports backwards. So this is, I'm running it on another computer over here. As you can see, I'm running Big Sur, and I am accessing that Docker container running on the machine up here from over here. Like I said, without, you know, having to move it around or putting it on the local machine. So it's just a way to expose sort of services on the local network. Cool beans. Okay, so let's go back and look at Kubernetes, because that's why we're here, right? So what we can do is, I'm going to actually do, a build, and I'm going to tag it CC demo 2. So basically, so the first time we pulled the Docker image, cool, right? But I'm actually going to build it. And when I'm going to build it, I'm adding this extra tag here, which, or the, flag that will automatically load it into the kind cluster for us. So we've got the kind cluster that's already running over here, and we're just going to do, so this is going to take a moment, but what we'll do is I'll open up another browser, another tab. I'll open up my favorite Kubernetes inspection tool, Octant. So Octant is an open source app that was built by VMware and some good folks inside. And as an open source, it's part of the community, and it is a great way just to visualize. It's like an Uber dashboard really for Kubernetes, so we can see all the different services that are running, all the different pods that are running. So if I look at pods, for example, I don't think it has been loaded yet because it's still building. But yeah, so you can see now as far as the build goes, we'll roll back a bit here, so it's pulling the Scott Wells. It's going ahead, starting a builder container. It resolves all the layers, grabs all the layers, verifies the SHAs, and then executes the Docker file. So sets the work directory, copies the app, runs Hugo extended. That goes ahead and does the site creation itself. And once it's all done, successfully built. So now it's going to actually just load it into the cluster. So it takes a moment or two to kind of get that put in there. But if we come back and we look at pods, gotta love the waiting for things to build part of the demo. Now, of course, performance is a thing, and we are going to be working on certainly improving some of that. We have some really good architecture changes that we're doing that'll, improve the performance a lot. We did what we need to do in order to try to achieve compatibility, particularly with the OCI spec. And, now that we have that, now it's about optimizing for performance. Changing it up. Just to verify that it is still working. So you can see the containerd shim process here is doing all the work right now. While it's going, actually, let's do some cleanup. Just going to stop the other container there. Still loading. Now, that being said, we could have done it the manual way where we just literally do kind, is it container? Yeah, kind load Docker image, and then whatever the name of the Docker image, and it would do that. It takes equally as long or so. So gotta love when that works like 2 seconds earlier, and it doesn't work in this exact moment. In any case, the demo, the way that it's going to eventually go, is that pod shows up here in the list, and once the pod shows up in the list, actually we can do some cool things like port forwarding, and instantly access it and things like that. I don't know why it's being funny here. Well, that's always fun, especially when I know it's going to work. It just takes a minute, but it's taken a lot longer than it did before. That being said, Octant is really awesome. I'm a super big fan of this as a tool because you get this really great look at your cluster from a high level view. And you can see up here in the corner, we've got kind running, but I've got other, contexts, so I can easily switch to like my production environment, for example. And, you can see exactly what's happening there. There we go. Okay, cool. So there, that finally finished. Let's go back and take a look at the pods. Why not? All right, it's loaded. I got to actually do the deployment now. Okay, cool. So that's just a matter of kube, apply. Oops. So inside of my folder man YAML, I have a deployment script there, or a deployment YAML file. And instantly you can see as soon as I ran that, there's my 3 pods that are running. If I do code, just to show that again, this is that deployment file. So you can see we've got 3 replicas. It's using the apps called MRS Hugo Test, Microsoft. And it's going to use the CC demo container image that we just loaded. So if we go and look, I feel like I have a typo and it's going to complain. But yeah, it's complaining because I doesn't have the right I don't think I have the right image. Yeah, because I gave it the wrong. I did CC demo instead of CC demo 2. Dope. In any case, if I had done the right thing when I created the image and loaded it up, it would have loaded the correct image into the cluster. Yeah, see CC demo 2. And then my YAML file has CC demo 1. So if I actually just change that real quick, we can get the deployment to do it. CC demo 2. There, much better. So now if we go back to the pods, we'll see, okay, those 3 ones that are broken, oops. But here we've got the ones that are proper. So the deployment's smart. It detected the new image in it. It set it to the right container image. and then assigned the service to it. So now I can just quickly hit this button here and port forward, and voila, the fancy microsoft.com running in my kind cluster on Kubernetes. It was a little sketchy getting there, but we made it happen, and all within the 30 minutes, I might say. So that's really the end of sort of the demo. That's what I wanted to show you folks today. I think, you know, Octant is a really, really awesome tool. It's easy to install with Brew. And, you know, it's your Uber dashboard for your Kubernetes clusters. And when you combine that with Kind, you know, you have this really easy, quick way to load up your images locally. And I think, you know, given if I had a lot more time, what we would do is like, okay, let's hack the image, make changes to it, rebuild, reload, and try to do that in a way that's really tight on the inner loop there, as opposed to sort of this, you know, the bit of a contrived demo that we're doing here. So I'm going to take a look at the chat here and see what we got. Eric, anything else that you want to mention while we're here?
I don't know. I enjoyed the demo. I like what I'm seeing here, and I love the idea that you've done the complete integration with Kubernetes. So yeah.
Really sorry I missed the messages in the Zoom there, so I wish I could have gotten the size a little bit bigger on the font. I hope that it came through for some folks.
Yeah, that's what I was talking about when I brought that up. But you were on your last slide, so that one that you did the demo was a little fuzzy, so you couldn't really see what was on the screen. So, you know, classic. What does it actually say?
We learn. Yeah. This is how we learn. Yeah. So Russell, quickly to answer, Alpine. Yeah, for most of my stuff I use Alpine. Sometimes internally I use Photon. I'm a big fan of Photon, but it doesn't have the same sort of flexibility. So Alpine's great because it's got everything that you could need in Linux. It's very hardened, very secure, minimal. Historically, I'm a Gen 2 guy. I used to run a data center that was all Gen 2 Linux, so I'm a bit of a psycho like that. But so Alpine's very friendly to use and super as far as you know, the features there go. Has Photon been added to the harbor for security scanning? I'm not too sure. I believe so. Don't quote me on that. I know that it's I know that the security scanning in Harbor is kind of new, so I know that Photon is also a first-class citizen. So if it's not on there yet, I'm sure it's something that's in the roadmap. Photon's going to be issuing a new release in the next bunch of months that might align, and they might just do it in like Photon 4 instead of the current branch. But I can follow up on that. We're going to be doing a little bit more outbound stuff with Photon. So I own, my title is, you know, product marketing developer tools. I sometimes product manager for the first half of the year, and I'm product marketing like the last half of the year. But so I own Fusion, Workstation, as well as Photon OS. So I think, you know, the CRX runtime that we built is all based on Photon. The container runtime that we have is all based on Photon. So I think that, you know, we're very interested in it. It's a really cool little appliance OS that I think has a lot of potential, that particularly in the container space.
All right, well, we're at the top of the hour. So Mike, thanks a lot. I appreciate the session as well. And just to remind people, we're doing the hackathon this afternoon at 4. So if you want to hang in with us, it should be fun. We'll announce the award winners. We'll also announce the script winners. So thanks for being here. And there are other sessions in this track. So go check it out, and we'll see you at 4 for the hackathon.
And I'll be one of the judges. So just as an FYI, I do accept bribes.
That's not fair. That is not.
I'm kidding. I do not.
In 2020 land, I don't think there is such a thing as fairness or normal. So yeah,
here we are.
Take bribes, whatever. All right. Thanks a lot, guys. And
thanks, everyone.